Right guys, now let's see how to work with these three formulae, and they're pretty important, I can say, because these will be used into parametric functions and also differentiating one function with respect to another one. This will give you 4-mark problems in the examination, so pretty important. Know this formula and see how they are generated. All right, so the first thing is sine 2 theta in terms of tan. All right, so is this valid? Do you think this is right? We know that sine 2 theta is what? Sine 2 theta is actually 2 sine theta and cos theta. This is what we know, isn't it? Now, is this the same thing? Let's see. If I can write, let's say sine 2 theta, is that equal to this, to tan theta by 1 plus tan square theta? Let's solve this guy. So 2 sine tan theta can be as sine theta divided by cos theta. Yes, and this guy is 1 plus sine square theta by cos square theta. Take the LCM, that goes like 2 sine theta by cos theta, and here if I take the LCM, that becomes cos square theta, and this cos squared plus sine squared, right? Cos square theta plus sine square theta. What happens here? This looks like 1, correct? So I can write this as 1. My question will be 2 sine theta divided by cos theta, the whole thing divided by 1 by cos square theta. So these guys go along, right? So that goes like 2 sine theta into cos square theta by cos theta into 1. So I can see 1 cos and 1 cos is gone. So what left out is 2 sine theta cos theta, which is looking like this formula, which is nothing but sine 2 theta, which is my right hand side, is sine 2 theta. See, so I can say sine 2 theta in terms of tan as 2 tan theta by 1 plus tan squared. Similarly, it goes with 1 minus tan squared by 1 plus tan squared is actually cos 2 theta. You can substitute sine squared by cos squared, sine squared by cos squared, and check this out. You will get that formula, right? So now let us know that these formulas are true. These are from your first PUC basically, and see how they make problems out of this. Okay, problems are based on substitution of trigonometric functions. All right, so if they can frame a problem here, it look like y is equal to sine inverse of 2x by 1 plus x squared. So if this is my question, okay, it should look like one of these forms. So 2x 1 plus x squared, or 1 minus x squared 1 plus x squared, 2x 1 minus x squared. Difference between these two guys are very simple. There's a plus here, there's a minus here. If there's a minus, it is sine 2, right? If there's a plus, it is sine 2. So if this guy is what you're looking for, right? So this looks like the first formula, and from the first logic, if this is sine inverse, this whole thing has to become sine. How I can make this whole thing sine? By putting x as something? Yeah, you need to know this formula. That's it. If I take x as tan theta, see what happens. That looks like y is equal to sine inverse of 2 tan theta by 1 plus tan square theta. Now what is the answer? So sine inverse of this guy looks like sine 2 theta. Very simple. And I can cancel this out. Y is equal to 2 theta. Now who's theta? Theta comes from here. Theta is nothing but, I can write theta as tan inverse of x. That's it. Yes. So it goes like 2 times tan inverse of x. So that is y. Differentiate this guy, see what you get. Dy by dx, 2 is a constant, and 1 by 1 plus x squared. That's your answer. Very important formulas and very important substitution problems in differentiation, and they give you quite a lot of marks. Right? They ask you 3-mark question or 4-mark question. Sometimes it is all about this. Let's go ahead and try to do another problem with this guy. So how can they frame a problem for this second one? If it is cos, y is equal to cos inverse of 1 minus x squared by 1 plus x squared. It looks like this. Now, then who's x? See, look at this. If I know this formula, I can guess very easily that x has to be what? X has to be tan theta. See, x has to be tan theta, and so what happens to my problem? It looks like y is equal to cos inverse of 1 minus tan squared theta by 1 plus tan squared theta. And I can see that becomes cos inverse of, I can write this whole thing as cos 2 theta. So what happens here? Cos and cos is gone, so y is equal to 2 theta. Who's theta? Theta back again. Substitute theta as what? Tan inverse of x. So I can write y is equal to 2 into tan inverse of x, and what's the answer? Y dy by dx is 2 times 1 by 1 plus x squared. That's your answer. This answer are all same. Right? You can actually guess now what the answers are, right? So let's do the last one here. Let me do it here itself in small space. If my question is y is equal to tan inverse of 2x by 1 plus 1 minus x squared. So this guy looks like the third formula here. I'll take x again as tan theta, see what happens. It looks like y is equal to tan inverse of 2 tan theta by 1 minus tan squared theta. This guy looks like tan 2 theta this time, alright? So what happens to my problem? It looks like y is equal to tan inverse of tan 2 theta, and tan is gone, so y is equal to 2 theta. Theta is who? Again, tan inverse of x from this substitution. Differentiate this guy, tan dy by dx is nothing but 2 into 1 by 1 plus x squared. All the three answers are same, isn't it? Can they complicate questions a little more? Yes, if at all. Instead of x, they ask you something else. Let's say we'll go with the first type itself and see how they can complicate this problem a little more. If my question was y is equal to sine inverse of 2 times, let's say e power x by 1 plus e power x the whole squared, yes, this still looks like this form, that is 2 tan 1 plus tan squared. So what can I do here? I can just write y is equal to, or I can just substitute e power x is tan theta and convert my whole problem like the first one, that is y is equal to sine inverse of 2 tan theta by 1 plus tan squared theta, and my question will become y is equal to sine inverse of sine 2 theta. And what happens? Y is equal to 2 theta. Then who's theta? Theta from here. Put tan here. So y is equal to 2 times tan inverse of e power x. And the answer is what? dy by dx is 2 times 1 by 1 plus x squared into differentiation of e power x is e power x. Right? That's how it is. Similarly, they can ask you another function here. We'll do that problem. So now, is there any shortcut which can be used to do this whole problem in 5 seconds time or 10 seconds times? Yes. If my question, I'll rewrite the same question. Y is equal to sine inverse of 2 into e power x by 1 plus e power x the whole squared. If this guy is looking like my standard formula here, let me write a standard formula here. Sine, just write like sine y is equal to sine inverse of, let me write as 2 into function by 1 plus a function whole squared. This is the standard formula I am making from this formula, right? So it looks like that, 2 into some function 1 by 1 plus some function whole square. If that is the question, whatever is this function, I'll take e power x as tan theta and separate theta from here. Who's theta? Theta is tan inverse of e power x. This is what I have to do. Take this function as tan theta, separate theta, differentiate this guy, that'll be your answer. Look at this. So dy by dx, I'll take this as y is equal to so much. I'll just take this y as whatever theta is and differentiate this guy. How do you differentiate? 1 by 1 plus e power x the whole squared into differentiation of e power x. Is this not my answer? Yes. Okay, this guy is not x squared, this guy is e power x. I'm sorry for this, this is e power x whole squared. Whatever comes inside has to come here. So very simple. Now if my question was not this, if my question was, let's say y is equal to sine inverse of 2 times log x by 1 plus log x the whole squared. So what would be the answer if I have to do it directly in 5 seconds, 10 seconds time? I will just take this whole thing, that is log of x as tan theta, separate theta from here. Who's theta? Theta is tan inverse of log x and differentiate this guy. Okay, take this guy as y and differentiate. That answer would be 1 by 1 plus inverse, tan inverse of differentiation is, or inverse differentiation of tan inverse is what? 1 by 1 plus whatever is inside whole square, that is log x the whole squared into differentiation of log x is 1 by x. So that's your answer. It takes hardly 5 seconds to finish this if you know the general format of these 3 problems, right? So let's go with the second guy and write the general formula of that and see how we can use shortcuts based on this also. Let's say I have something like this, right? That is y is equal to cos inverse, this time cos inverse of 1 minus x squared by 1 plus x squared. This is the more general form for this. All right, so now I can also write y is equal to cos inverse of 1 minus whatever function whole squared minus the same function the whole squared. This is my general format. So let's say I have y is equal to cos inverse of let me say this is a problem like 1 minus secant x the whole squared by 1 plus secant x the whole squared. Now can I solve this problem? This guy looks more like this, 1 minus tan squared, 1 plus tan squared, but I don't have tan squared here, I have a secant squared. So this whole thing will not become cos 2 theta unless I have a tan squared here, right? So what I do is I'll just write secant x as tan theta, and I converted my problem in terms of 1 minus tan squared, 1 plus tan squared. So what happens to my problem? I can see my whole problem would become like that. Alright, so if I write this, guys, y is equal to cos inverse of 1 minus tan square theta by 1 plus tan square theta, and my problem would look like y is equal to cos inverse of cos 2 theta. From which formula is this? From this guy. Cos 2 theta is 1 minus tan squared, 1 plus tan squared. Now my problem would be what? This is gone, y is equal to 2 theta, and who is theta? Theta I get from here. Put this guy on this side, what do you get? I get theta is what? Tan inverse of secant theta, right? Secant x, that's it. So I'll write this as 2 times theta is tan inverse of secant x, and put here y is equal to 2 times tan inverse of secant x, and can I differentiate this? Yeah, 2 into 1 by 1 plus whatever is inside the whole square, that is secant x the whole square, into differentiation of secant x. So what happens to my problem? 2 1 by 1 plus secant x the whole square into, this is secant x into tan x. That's it. I can further solve this as we can solve this, so let be till there. Now can you get this answer in 5 seconds or 10 seconds time? If this was a CET question, yes. If this was my question, okay, let's take the question back again. I will not solve any of this, but still I can write the same answer. How? If y is equal to cos inverse of 1 minus secant squared x by 1 plus secant x the whole squared, or squared here. If this was my question, and I know that if I know that formula 1 minus tan squared, 1 plus tan squared, I know that this has to be tan. So I'll just write secant x as tan theta. Let the time starts now. Alright, so that was my question. I know that this guy has to be tan. I just took secant x as tan x, or tan theta. I will find theta. What is theta? Tan inverse of secant x, and I'll differentiate this guy. My answer will be differentiation of this. That's it. So whatever theta, separate this guy, differentiate this guy. So dy by dx would be 1 by 1 plus secant x the whole squared, and with the 2. The 2 comes from here. The general form, it has to be 2. Because I get this as what? Sine cos 2 theta inside. So there should be a 2. So keep this in mind. 2 into differentiation of this guy is secant x into tan x. And that's it. That's all about it. So these are a couple of things, if you know before you go to the exam, if you practice, if you understand, and if you remember these formulas and the final answer formats, you get the answers straight away. Okay, that's all about it. What of the last one? Can you guess how to work problems on this? Yes. Let's work at least one problem on this and the general form, and stop this class of substitution. Anyway, here I have the last one. Tan of 2 theta can be given as 1 plus or 1 minus, or right, 2 tan theta, sorry, by 1 minus tan square theta. This guy. Here in this case, I just have y is equal to tan inverse of 2x by 1 plus or 1 minus x squared. I can still solve this guy. Doing what? I just take x as tan theta and we go ahead and solve it. We did this problem in the last video, right? But now, if my question is more like y is equal to tan inverse of 2 times any function by 1 minus the same function whole squared, this function will become tan theta, so that I can cancel out with this tan inverse. Let's take a problem. If my question was y is equal to tan inverse of, let's say, 2 times log x divided by 1 minus or log x the whole squared. Now what should I do? If I know that, I know 2 tan theta, 1 minus tan square theta, it should become tan 2 theta, and I have a tan outside. So this guy will cancel with the tan 2 theta inside. So I will take this function, simply the log of x as tan theta. See what happens. Tan inverse of 2 into tan theta by 1 minus tan theta the whole squared. Yes, that's what I have. So that becomes tan inverse of tan 2 theta. And I can see that tan is out. So y is equal to 2 theta. Who's theta? Theta from here. That is tan inverse of log x. So that becomes y is equal to 2 times tan inverse of log x. Differentiate this guy. What is the answer? 2. 1 by 1 plus log x the whole squared into 1 by x. That's your answer. Right, I hope you understand this. These three are very important formulas and substitution problems in differentiation. Keep that in mind. They would come in the next 2 topics I'm doing, that is parametric functions and also differentiation of one function with another function.